Do you feel the vibes?
Okay, so here we go. So we had sine of negative 15. We have to write it as a combination of two angles. You have to start from that, right? 30 minus 45 does make negative 15. And so now, try not to refer to these all the time. And we're just going to go, right, with the, just, you're laughing, but learn that song, right? Sine, cosine, cosine, sine, okay? So here we go. So it's going to be sine of the first, cosine of the second, minus or plus? Minus cosine, sine. And then I always check, right? Sine, cosine, cosine, sine. Okay. And then I have 30 and 45, 30, 45, 30, 45. So now, sine of 30, I go on my triangle. How much is it? 1/2. Cosine of 45, 1 over root 2. Minus, what's cosine of 30? Times sine of 45, 1 over root 2. Let me show you one other thing. With the sines and the cosines, if sine of 30 is 1/2, cosine of 30 has to be the other side, root 3 over 2, right? So once you use one and you're sure, you could just use the other one for the other one. So now, this one gives you 1/2 times this. It's going to be 1 over 2 root 2 minus root 3 over 2 root 2. So altogether, 1 minus root 3 over 2 root 2. Okay? Okay, you know what? I'm going to give you guys another one to do. Yes, why don't we do, okay, D. Why don't we do a cosine this time of, let's see. Let's do 345. Why not? Yeah, 345. Yeah. So how can we do this? So how can we write 345? No, not multiple. You're not going to do A plus B plus C. No. But we never venture into like the bigger angles on the unit circle, right? Because look, over here, you have the 30, the 45, and the 60. What's the corresponding angle to the 45 here? 135. You could do, yeah, so, and then what is it here? That's, this is 225. Okay, and then this one here is 315. Ah, oh, okay, so you could do 315 plus 30. That'll make 345, right? So this is going to be cosine of 315 plus 30. So now that's going to be, what's the song? Sine, cosine, cosine, sine, and then cosine, cosine, sine, sine. So cosine, cosine, minus or plus? Minus sine, see? Sine. Okay? And then you have 315, 30, 315, 30. Cosine, cosine, sine, sine. Back during COVID, when I used to teach this at home, right, on Zoom, my son, who was like, I don't know, 5 at the time, he would just hear me singing it. And so he would sing it himself, but it would be like sine, cosine, cos. Like he thought it was like sine co. Like he didn't know where sine ended and cosine started. But like he would just sing it all day long. Sine, cosine, cosine, sine. It was like a blessing and a curse all at the same time. Okay, so now cosine of 315. Which triangle are we going to go for this one? The power of 4. So what's the value? 1 over root 2. But cosine in the 315 quadrant, is it positive or negative? Ooh. Cosine? Positive. So 1 over root 2. And how much is cosine 30 these days? You would know because you've got the triangle. Look at root 3 over 2, even on Mondays. Now, sine 3, so minus sine 315, how much is it? This is negative 1 over root 2 because in that quadrant, sine is negative. Hang on. Sine of 30 is what? 1/2. So now look. Here we have root 3 over 2, root 2, root 3 over 2, root 2, minus plus 1 over 2 root 2. Oh my God, wouldn't you know it? We like got the same answer again. Okay? But you can't just like guess the right answer. Like you have to, show me some work. So when you're doing these on your homework, right? Venture into like, God forbid, the third and the fourth quadrants as well. Okay? Right? There is like stuff out there. Okay? Isn't that cool?
Yeah.
What a cool lesson this is.
So cool.
Okay, now what if it's in radian? What if it's something like, oh my God, 11 pi over 12? What? What do you do then? Well, I'll tell you. No. We have to rewrite 11 pi over 12 as a sum of two special angles. So what are the special angles? Like pi over 3, pi over 6, 2 pi over 3, 5 pi over 6, 7 pi over 4. Any one of those is fair game. So here is how you do it. You're going to rewrite the fractions as two separate fractions with a denominator of 12. And then, okay, we're going to put the pi's as well, right? Because it's something pi over 12. Now, we need to find numerators that add or subtract to 11, but they need to reduce to a special angle. So, for example, this is what we had. Okay, so follow me on this. This is what we had. Now, let's go systematically here, right? Because we want to like go in order. So two numbers that make 11. One possibility, don't write this, but one possibility is 1 and 10. Now, is pi over 12 a special angle? No. Does 10 pi over 12 reduce to a special angle?
Yes.
It could be 5 pi over 6, but pi over 12 is not a special angle, so I can't use the 1 and 10. Hang on. So instead of 1 and 10 then, why don't we do 2 and 9? That adds up to 11. 2 pi over 12 reduces to pi over 6. 9 pi over 12 reduces to 3 pi over 4. Okay, those two are usable and I can use those. So this is how you have to do it. Okay? All right, so let's do another one here. Sine of 7 pi over 12. So this is going to be sine of okay. So 1 and 6 doesn't work, right? Because 1 over 12 doesn't work. So then I do 2 and 5. Does that work? How about 3 and 4? 3 and 4 reduces, right? Because, so here it is. When you reduce them, this becomes sine of pi over 4, which is a special angle. Sine of pi over 3, also a special angle. So what's the song now? That's the one. Sine, cosine, cosine, sine. Okay, so sine, cosine, minus or plus? Plus, cosine, sine. Okay, so let's see. Sine, cosine, cosine, sine. Pi over 4, pi over 3, pi over 4, pi over 3. Same order. Okay. Okay, Maddie, sine of pi over 4? 1 over root 2. Okay, Kieran, what about cosine of pi over 3? You can look at the triangles here. Cosine, 1/2. 1/2. Plus, okay, Marley, cosine pi over 4? 1 over root 2. Okay, Ari, what about sine of pi over 3? That's the one, root 3 over 2. So here I have 1 over 2 root 2 plus root 3 over 2 root 2. Altogether, 1 plus root 3 over 2 root 2. Again, surprise, surprise. Okay. Pi over 12. So now we're going to have cosine. Okay, we're going to get pi over 12. Isn't it easier to subtract 2? Right? Because if you're going to get, like, if you want to end up with a 1, you want to subtract 2. But then even if you use 0, then the other one would be pi over 12, so that doesn't work. Yeah. Okay. So what do you think? 6 and 5? Okay, so you want to get 1 pi. So I want to do something minus something. Why don't we go in order? Yeah. Well, how would we get that though? So what if, yeah. So they have to, okay, so what if we do like 2 pi over 12 minus 1 pi over 12? That doesn't work, right? Can you do 4 minus 3? You can do 4 minus 3. You can even do 3 minus 2. The possibilities are endless. Let's do 4 minus 3. So this is cosine. What is this? Pi over 3 minus pi over 4. Okay, I'm going to let you guys do this one. Are you ready? You ready? You don't have a choice. On your mark, get set, go. Remember, this is a cosine. Go, go, go. Cosine, cosine, sine, sine, right? So cosine, cosine, plus sine, sine. So what's cosine of pi over 3? 1/2, 1 over root 2. Okay, Robbie, what about sine of pi over 3? Root 3 over 2. Sine of pi over 4, 1 over root 2. So finally, this will be 1 plus root 3 over 2 root 2. Now, these identities, right? These identities, you can always go that way, but you can also go this way. So for example, if I was walking down the street and I saw a billboard, and on the billboard, it said this, right? This thing here, where it says a sine pi over 3, cosine pi over 4, and so on. Immediately, I would recognize that pattern of, oh my God, sine, cosine, cosine, sine. That's like the identity. And look at the angles, pi over 3, pi over 4, pi over 3, pi over 4. So sine, cosine, cosine, sine is just sine of a plus b. And here, look at what the angles are. This is A, this is B. This is A, this is B. So I would say, oh my God, this is just, is it sine or cosine? Sine pi over 3 plus or minus? Plus pi over 4. Which is, now I got to add pi over 3 plus pi over 4. So this one, we're going to make it over 12, right? So it's going to be sine, and then the common denominator is 12. So let's see. So we're going to multiply this by 4 over 4. And we're going to multiply this 3 over 3. 4 pi plus 3 pi, 7 pi over 12. Yeah. Yeah. Okay. Yeah. Okay. Next. What about this one? Oh my God, that could totally be like the tangent one. Okay? Because look at the tangent. It's tangent of the first plus tangent of the second over this. So look at that last one. Is it tangent A plus B or minus B? Look at this one. There is a minus here. which means it's this minus 1 there. So this is going to be, no, sadly, but you're more than welcome to come up with it. Tangent of 78 minus 18. How much is that? Tangent of 60. But wait, can we come up with what tangent of 60 is? 60 is this one, the pi over 3. Tangent is root 3 over 2 over 1/2. So just root 3. Okay? That's it. That's the answer.
So, wait, don't you have to put it over the...
We did. No, because the whole thing, that whole thing is just tangent of a minus b. Look at this one here. The whole thing, numerator and denominator, is tangent of a minus b. Okay? Question.
No, I was going to say,
Oh, because it's the first angle minus the second angle. You see that? Yeah, you got to keep the order. Okay, so let's simplify these. Okay, so let's simplify these. We're going to do sine. Okay, so this is a plus b. Sine, cosine, plus cosine. Oh. Sine. Okay? But now you simplify whatever you can. So sine of 30 is 1/2 cosine x, plus cosine 30 is root 3 over 2 sine x, and that's how you leave it. Okay? Here, this one, cosine plus sine. There is nothing to simplify here, and I just leave it that way. Right?
shouldn't it be negative y?
No, because cosine, the negative changes to positive. You just take it as is. Yeah? Okay, this one. Sine, cosine, sorry, what is it? Sine, cosine, sine. So sine, pi over 4, cosine x plus cosine sine. Right? Did I do that correctly? Sine, cosine, sine. Pi over 4x, pi over 4x. Sine of pi over 4. Noah, how much is sine over pi over 4 these days? 1 over root 2 cosine x plus 1 over root 2 sine x, and I'm done. And now for the that's right, the grand finale. We have to solve this entire equation. So look at this equation. It's all of this. Do you see that?
Over the interval.
Over the, okay, that doesn't, ignore that one. So it's all of this. But do you see how when you zoom in here, we really have to divide and conquer this one? This one is just one of the problems that we were just doing in example 4. This one is another one of those. We have to do those separately and then see what comes of this thing. So why don't we do the red one first? Cosine minus sine. That's it. Oh, were you? Yeah. You can. No, because I'm just using that as like an intermediate to what we're going to do here. So now take a look at this one. Now we're going to do the blue. Again, it's cosine, sine. So cosine plus sine equal to how much? 1/2. Now let's simplify. What's cosine pi over 3? 1/2 cosine x minus root 3 over 2 sine x. Is that right? Plus cosine pi over 3, 1/2 cosine x plus root 3 over 2 sine x equal to 1/2. When you do this, there are going to be things you can cancel and things you can combine. So look at this. Negative root 3 over 2 sine x, positive root 3 over 2 sine x. Can I just get rid of those? Let's do it. So let's just rewrite what we have left. 1/2 cosine x plus 1/2 cosine x equals to 1/2. No? What's 1/2 an apple plus another half of an apple? A whole apple. So 1/2 cosine x plus 1/2 cosine x is 1 cosine x equals 1/2. Oh my God, I can totally solve that one now, right? That's what we were doing all of like in the last lesson. So where is cosine equal to 1/2 for which angle? Is it pi over 3? Pi over 3 it is. But there has to be another quadrant. Cosine is positive here and here. How much? 5 pi over 3. Isn't that super cool? Say yes. Yeah, there you go. There you go. Okay, so now...
Press start.